Hey everyone, welcome back to my channel. In this video, I'm going to be continuing my data structures and algorithm series, and today we're going to be talking about merge sort and how we can implement that in Python. So merge sort is another way of sorting. I've already made a video on insertion sort and bubble sort. You can go check them out. But merge sort is basically where we divide and conquer a list. So we break it into many halves, and then we sort the list, and then we merge it. So it does have a lot of steps to it, but the advantage to merge sort is that it's very fast when you're sorting a huge, like a very large list. When it's a really short list, like methods like bubble sort may be faster, but most of the time when you're sorting a list that's very large in number, merge sort is one of the most efficient methods for that. So for the code, we're gonna have a function merge sort, and then we're gonna print the list at the end. I decided to go with a short list because I didn't want it to be too complicated, but again, this algorithm can work for a list of any size. Now here, this is all gonna be run through a recursive approach. So what that means is that basically we're gonna be calling the function when we're defining it, and to prevent this from going into an infinite loop, we're gonna make sure that this recursion stops when we've reached the elementary sub-arrays of the main list. So what that means is basically when we half each section of the list until we get to the very basic elementary parts of the list, and then at that point when we can't divide it in half anymore, that's when the recursion stops, and then we sort it, and then we merge the list back together. Okay, so to do that, what we're going to do is we're going to have a midpoint so we can actually divide the list in half. And so we're going to do that by doing floor division of the length of the list, and then we're going to use slicing to slice the list into two parts, a left side and a right side, so the first and second array. Now we're gonna merge sort the left side, so we're gonna run this function again, and then we're gonna do the same thing with the right side, and then once it's all been divided into lists that are very small, like only like one element big, then what we're gonna do is we are going to make these three variables. It's gonna be the left index, the right index, and the merged index. Now this is the left index is what we're going to be using to index through the left side of the list, and the right index is going to be the right side, and the merged index is going to help us determine what the final merged list is going to look like. So this is where the merging part happens. So we're going to set these all to 0 because that's we're going to initialize this process with just a value of 0. And now we're going to have these two conditions. We have to make sure that the left index is less than the length of the left list, and the same thing with the right list. This way it keeps the list index from going out of range. Okay. So here we're going to begin with the real merging process. Now that everything's been reduced to the most basic parts, and now we're going to start to kind of sort the list. Okay. So if the if the index of the left list is less than or equal to the index of the right list, then we're gonna take the merged list, and we're gonna set that value to the left index. So what that means is, let's say that the value of these two variables right now is 0, right? So that means the first element of the left list, if that's less than or equal to the first element of the right list, then the first element of the merged list will be equal to the left list. Because again, we're going from ascending, we're going in ascending order, so we want the smallest numbers to be in the front of the list. So then we're gonna increment the value of the left index just so that this can keep on going, and then we can compare the next element in this list. Now, what if the right index is actually greater than the left index? Then we're gonna do the same thing, except this time it's gonna be the exact opposite. And here we're gonna set the merged index to equal to the right index. So essentially what we're doing here is we're basically comparing the left and right segments, and we're deciding which element are we gonna put in the merged list first. So for example, here in this example list, if we have 1, 4, 2, 3, and 5, 7, 8, 6, the first list is gonna be the left list, and then the second list is gonna be the right list, right? So here we have to decide in our merged list which is gonna be the first element. So let's see. Let's compare the first element of the list. Let's compare the first element of the left list to the first element of the right list. Now, since 1 is less than 5, we're gonna add 1 first. And now we're gonna compare 4 and 5. And so now we're gonna add 4 because again, 4 is still less than 5. And now we're gonna do the same. We're gonna do the same thing until we have a sorted merged list. Okay. So this process we're gonna keep repeating it until one of these conditions is false. So like for example, if we've indexed the left list so much that at this point, if we index it anymore, there's nothing left to index. If we index the entire list, then this while loop is gonna end. However, we're still not quite done yet, because what if the list isn't an even number? What if it's an odd number, or like, so what if the lists are of different lengths? Let's say the left list is gonna be just the first 4 elements, and then the right list is gonna be the next 5 elements, right? The last 5 elements. So here, what we want to do is we want to make sure that we don't leave any of this sorting process out. So what if we've exhausted the left list, so the while loop ends, but we still need to sort some stuff in the right list because that's not done. So we're just gonna make sure that we do another check, we do another sorting and merging thing, so that this way in the end we're gonna have no errors. Okay. Here, if you want to see, okay, so first we're just gonna run this and see how it turns out. Okay, so again we have a sorted list. Now if I remove this, if I remove this part that I just talked about, the part where we make sure that we don't leave anything out, and then if I run the list, if I run the program, as you can see here, it's not completely sorted, because look, 8 is coming before 6. This is because one segment of the list, basically one sub-array was exhausted, but the other part still had some unsorted segments in it. So that once we run this piece of code here, that's just gonna prevent anything wrong from happening. And now we're gonna have a sorted merged list. So yeah, that was it for this video. I hope you liked the algorithm, and I hope you liked the way I explained it, and I hope that you understood how the fundamentals of this algorithm works. Now, in the next video, I'm planning to make a quick sort code. So do check that one out when I release it. So yeah, that was it for this video, and I'll see you in the next one.